Greetings, PolyPodcast fans. Peter Dyke here with yet another edition of the PolyPodcast. Today I am joined by my good friends Alan Ambler and Dan Landy. Before we say hi to those two guys, let's say thank you to WL Plastics for sponsoring another PolyPodcast. We're very thankful for WL and their support, as we are with all of our members that help us bring this great content to our audience every month, every week, and pretty much every day. So today I thought we would sit down with our two engineers and talk in detail about some of the things that they're hearing from the field every week. You know, central to our mission here at the Alliance is bringing our content to municipal specifiers, municipal staff, as well as consulting civil engineers. But another thing we've found useful over the years is to bring the content to our members and our members' staff, who can then take that information out to the field as well, so we have more people talking the same, or using the same message with all these various issues that we come up with. So today we thought we'd go back a couple years and grab a deck that we used at Showcase in 2022 and update it with some current information, but also at the same time just kind of rehash some of these issues because we have a lot of new people in the industry. So with that, Dan Landy, would you please introduce yourself?
Absolutely. Always looking forward to talk about the top 10 issues, even more than we're being asked on a daily basis, right? But my name is Dan Landy. I'm an engineer with the Alliance. A lot of these questions I'm getting are from personal trainings I do myself with seminars with consultants and owners, but we get them from contractors and distributors as well. Some of them more common than others, so we're looking forward to getting into them and getting a little bit deeper than a traditional conversation.
Great, thanks for that, Dan. Alan Ambler, you're up.
Hey there, Pete. Glad to be here again at a long week here at NASTT's No Dig that we all got to join and experience together, Pete. So glad we get to talk about the engineering problems that we have been brought to our attention at the Alliance. Over the years, the Alliance has been blessed to be now considered a resource within the community for all of its engineering questions. A lot of that has to do with the success of the Alliance's roadshow program and webinar program, which, oh boy, COVID kicked that one off in steroids for us, Pete. So very happy to be here, and we're going to share our experiences with everyone out there.
Well, thank you, Alan. Let's get started. You know, one of the questions we get a lot, guys, is how do we connect to legacy materials? And our standard answer for years has been the MJ adapter. But we've spent a fair amount of time in the end of last year in the provinces of Canada, as well as this year up in Michigan. And it kind of feels as though the megalug is making a resurgence, or actually, guys, it probably never went away. Alan, can you tell us a little bit about the preferred method known as the mechanical joint adapter?
Sure, Pete. So what we're seeing, if you are not afforded the opportunity to use fusion to make that self-restrained joint by melting the actual high-density polyethylene itself at a resin level, allowing that resin to flow across that interface to give us a joint that's as strong, if not stronger than the joint itself, then you'll have to use a different type of connection. They do not make for municipal use valves and other things like that that are fully polyethylene. So we do have to connect to valves and other appurtenances that are not polyethylene. We do so through a mechanical joint adapter. What we're protecting isn't necessarily the polyethylene. It is a bell and spigot system from pulling out away from that valve as we see it. So a mechanical joint adapter has fairly robust connections as to how we affix that to the polyethylene, normally through butt fusion of a molded adapter such as the MJ adapter. And then we use a bolt pattern and specific torquing of those bolts in order to be able to connect it to that non-high-density polyethylene or metallic part and piece, and then that becomes a restrained joint. So that is, in a nutshell, Pete, what the mechanical adapter is.
So you say it's a fully restrained joint, Alan, in legacy systems, we tend to pour a lot of concrete. Do you have to pour concrete on that MJ once you connect it to, say, a PVC line or a valve?
When we're a fully restrained system, we do not have to pour concrete in that manner at that time. So those thrust blocks and all that thrust restraint really is set up for protecting that bell and spigot system, which has no tensile forces allowable along that joint. So yes, we do not have to pour thrust restraint at an MJ adapter connecting to a valve.
And all of our distributor companies that participate in the Alliance, Alan, they all sell those MJs, right?
They do. Comes as a kit.
So Dan, the old way of doing it, and I guess the current way in some places, is still the Megalug. Tell us about the Megalug.
Yeah, I was surprised you led with this question today because this is something I feel like we've softened our stance on recently. We've always been, MJ all the time, anytime you make a connection. And Alan, to your point, I like how you made the delineation between using it for a thrust anchor or a thrust block, but also for coming in and out of that valve connection. So that's where the difference is, in my opinion. So contractors, when they're putting valves together really quickly, you have a nice long run, you have a valve, a hydrant, something like that. They want to tie to those appurtenances really quickly. They are used to actually spending more time at the anchor points, right? So when you're transitioning piping materials, they are used to taking the time, pouring the thrust blocks, letting it cure, etc. But contractors, in terms of productivity, that Megalug on those, as you build out your water system, they do help you in terms of productivity. So that Megalug, strictly mechanical connection, similar to the MJ, it's just a little easier to put together. There's no backup ring, it's just a bolt down pattern like you see on a typical star pattern.
So you say, it's kind of funny, Dan, you say I'm softening my stance. I mean, really? No, I don't have a stance necessarily, except I think the best practice certainly is the MJ. But when we're out in the field, Dan, like we are every week, and guys are saying, I think the Megalug is great, but my guys are still want to use the Megalug, we need to educate and support what they want to do. We can tell them all day long the best practice is X, but if they want to do Y and they want help on how to do Y, I think it's our responsibility to help them.
Yeah, I do agree that the MJ is always going to be your best practice. I guess, in the role we have and the same position a lot of distributors are in, right? They're pushing the best approach out there in the market. It's hard to solve a problem, though, that isn't always there for the client. So people that have used Megalugs for a long time successfully, they don't have a bitter taste in their mouth, so it's kind of hard for us to tell them there is a better approach, even if we really do believe that to be the case.
So before we go too far down with the adoption in that manner, let's just talk about the basics of how the forces work within both of the systems. So an MJ adapter itself fuses onto the pipe. It does have a flange ring, a ring that comes and supports it. It depends on who manufactures that fitting as to whether or not it has an internal stainless steel stiffener, but there's enough meat in the body of the MJ as a molded fitting that it's going to, once bolted, take that force longitudinally along the pipe in that manner. A Megalug, it basically uses those bolts to drill down axially along the pipe itself, and so it definitely needs that internal stiffener for something to bite onto. So the way that the forces are distributed across each of these fittings are a primary differentiator between the type fitting itself. So,
and Alan, one of the key messages we've always given is, look, if you're going to use the Megalug that has more pieces and it's a little bit more complicated than an MJ, you've got to use that insert stiffener.
Absolutely. And it depends on the city's preference and their history of using it. So definitely, we're just letting you know, make your own decisions out there.
All right, guys. And one of the things when you're talking to an engineer about the best practice and how to connect, I often hear you guys explaining the Poisson's effect. Alan, could you give us a quick minute on what the Poisson's effect is?
Sure. So high-density polyethylene is a viscoelastic pipe material, so it can be flexible. When we go from a non-charged, so there's no pressure within the system, to a charged system, now the the pipe material will expand axially. Because it's expanding axially, it has a tendency to shorten on the edges. So once we charge that, so it's the actual activity of pressurizing that pipeline, then the ends, the restrained ends of that pipeline will tend to contract. For fuse joints, it doesn't matter, because that's a restrained joint, it just runs along there. So, but whenever we tie to something that's not polyethylene now, we're going to have to restrain that end in itself.
Thank you for that. You know, one of the reasons we need a restrained connection to legacy materials is because we worry that it's going to pull out. Other materials are using thrust blocks pretty much every time there's a bend in the pipe, right, Alan?
It happens, absolutely. If there's certainly a bell and spigot system where there's no restraint along that, or allowable tensile force along that bell and spigot system.
So, but there is a time when we need to use thrust blocks for polyethylene. Could you explain that, please?
Sure. When we are looking at thermal conditions, as to which there's change in temperature, either within the conveyed fluid that we have, or if we're running it above ground and we need to make sure that we're restraining that as well. Then when we're connecting at those terminal connections, we can use a thrust anchor. The two varieties that the industry offers is a butt fused piece, and it goes right into poured concrete, or you can use an electrofusion thrust restraint around on the outside, and it's directly electrofused to the outside of the pipe, and that gives us a little bit more protection from the pull-out forces that we may very well be able to find along that pipe run in itself. So your pipeline engineer, when we're looking at conditions that are not normal to be observed through that, as I mentioned, temperature change or higher pressure, they will look at those internal and external forces and make determinations.
Dan, you and I, thank you, Alan. Dan, you and I have been spending a little bit more time on the road talking about service connections. And, you know, similar to our acceptance of the megalug, you know, I think PPI might have a different attitude about the megalug, right? I mean, I think they're saying, you know, no, we don't want you to use it. But similar to our accepting the megalug, Alan Ambler, sitting around this table, Dan, for his first few years in Castleberry, used mechanical connections on HDPE pipe. I kind of look at Alan's use of that as a transition use. I mean, Alan, I don't know what you'd call it, but it's kind of a practical approach to how am I going to connect to this new polyethylene pipe that I think is great, but I'm not totally sold on how to connect to the pipe yet. Alan, do I characterize that correctly?
Certainly. As the education continues and the experience level of that community member, the municipality member starts to increase, they'll start to push much more towards fusion all the way through. But yes, you got it, Pete.
So two episodes ago on the podcast, I interviewed Todd Grafenauer from Murphy Pipelines, and we spent a fair amount of time talking about service connections. And honestly, Murphy still does not tell the client what kind of connection. They let the client tell them. And Murphy likes mechanical connections because they go on so quick. It's not a fully fused system, but they go on super quick, and you don't need the kind of training that you need with electrofusion. Alan, help me understand that and why the most prolific contractor in the United States is still not totally sold on a fused connection to the main.
Prolific contractor for pipe bursting. Just to correct that. Real
Thank
quick.
you.
So, yeah, definitely. So it depends on what they're trying to achieve. In that particular instance, if their ground is not corrosive, then they simply can use that mechanical fitting without issue as it continues to go through. Those agencies out there with very corrosive groundwater conditions recognize that the bolts or the mechanical pieces of the metallic pieces of the mechanical fitting may very well become a sacrificial anode, so to speak, for that location. But those fittings that we installed with Murphy Pipeline in the city of Castleberry from 2005, as early as 2005, are not failing, and that has a lot to do with the robustness of the fitting.
So Dan, one of the things that we'll show on certainly the YouTube version of this podcast is what's called a self-tapping tee. Could you explain the self-tapping tee, which Dan, I consider to be the best practice for connecting to a polyethylene main?
I do too. So it's fused directly onto the pipe, obviously using electrofusion, but it has a cutter in the tee itself. So once you drill down the cutter, you actually don't drill it, it's a little hex tool that comes with it. Once you get into the pipe, it retains the coupon. So once you lift it back up above that spring line, you do have live service. Now, that's a great option for 10 to 12 inch taps. Depending on the manufacturer, that's where they will no longer make those self-tapping tees. Anything larger than that, you are looking at a stainless steel tapping sleeve. One of our member companies, Robar, they make a great product. It actually will have an MJ outlet on there, so it's really easy to tie right into that medium diameter service connection. To answer your last question a little bit about people using HDP but not going fully in on these electrofusion services right away, I was reading a book from a doctor a couple weeks ago, and the guy's talking about people that recover from these cardiac events, and he said, if you've been unhealthy your whole life, right, I can't tell you to change overnight, you're not going to change. But the guy interviewing him said, well, what can people do? And he said, I tell everybody, drink 1 gallon of water a day. So he keeps talking, and later on he asked him about the gallon of water, and he said, if you drink 1 gallon of water a day, you're going to be healthier over time, right? But if I tell you you need to change everything, cut out sugar, salt, meat, everything at once, you don't want to change because it's too hard to change everything at one time. So as soon as I heard that, okay, most people think they can drink a gallon of water a day. Most people think that they can change their mains, but if you're telling them, okay, we're going to change your main, we're going to change the way you tap, the way you do services, everything at once, for those new users, I mean, I can see how people do get overcome with trying to change everything at once.
Yeah, well, what a great analogy. Way to go, Dan Landy.
Just some point of clarity, the service the self-tapping service line that's put on there, the spring line that Dan was in reference to is not the spring line of the main line. Nothing goes in that deep from the actual pipeline, but the spring line of the service line connection as we get there. So the second that we pull that service tap, that coupon back far enough beyond where flow can come through that service line, that's what's in reference to.
So Alan, that self-tapping tee is great, but with a self-tapping tee, I don't have the ability to put on a corporation, do I?
Yeah, most certainly, absolutely. So you could, off of the sideline, you could fuse on a polypropylene, polyethylene ball valve if you wanted to directly fuse it onto that service line connection, or you can go to threaded connection to a brass corporation stop. That is a few other connections, obviously along that service line, but the industry itself does have a electrofusion fitting that goes on the exterior of the pipe that comes with an embedded threaded connection that you can put that corporation stop right into, Pete. So there's lots of different options for you to be able to use whatever mechanisms you want.
So if we do want to use a corporation, that's available to us. If we want to go poly on our service or copper, that's available to us. We can run whatever material we want up to the curb stop. So we've really come up with everything that you could possibly want in that area of water service. Alan, tell me about on the lateral side, what's the preferred way to connect a sewer lateral to a sewer gravity main?
Okay, so a lot of that, what we're looking for is electrofusion wise to come off of the gravity sewer main, so that helps lessen friction loss from the side lateral as we get to the main. You're going to prepare the outside of that pipe, electrofuse that fitting right on, and you'll have multiple couplers that can get you back up to where that sewer lateral is. So a lot of times the sewer companies performing gravity sewer replacement or rehabilitation have to stop at a clean out. From the clean out to the property owner's house oftentimes becomes the property owner's responsibility, and a lot of times those sewer laterals happen to be PVC. So there are fittings that can come right in and use various forms of compression from the polyethylene pipeline, then connecting to that PVC lateral, Pete.
Hey, Thank you for that. Dan Landy, I've got one for you as it relates to bead removal. Let's talk about exterior bead removal. Why do we need to do that? And then if I do need to do it, how do I do it?
Yeah, so I want to remove those typically on slip lining projects. I'm not sure if Murphy recommends doing them on compression fit as well. I imagine they do, because when you're pulling it through the reduction die, they could bead up. You could have an issue there.
Yeah,
But on slip lines, definitely, you're already, with a slip line, right, you're taking a large pipe and you're putting a smaller pipe in there. So you're already taking a reduction in your hydraulics. If you can eliminate that bead on the external of your pipe, you're going to have a larger angular space, possibly getting into a larger pipe. You do want to give the contractor, a decent margin to get that pipe put into place, particularly if you're going around a small bend or something like that. So it is going to help actually during the installation. You can remove that on the smaller pipes with a mechanical little bead removal tool, and on the larger pipes there is a pneumatic tool that R&L Manufacturing creates.
Yeah, R&L does a great job. And Alan, on the inside bead, R&L also makes an interior bead removal tool.
That's correct. So if we have very low slope gravity sewer scenarios where the engineer specifies the removal of the interior of that bead, then you can go in and get that done. Obviously, prior to installation, there's not a whole lot of ability afterwards to be able to remove that bead after the pipe has been installed. So we got to make sure we do it at the right time. Now that has no effect on friction flow, so we do see it is uncommon for most applications, except again very low slope gravity sewers. Now, if that exterior bead, if you have more than enough ample room between the hose pipe and the slip liner, you also don't have to worry about removing the external bead. But that depends on your sizes and your application, and there you have it.
Well, here's one that's been coming up quite a bit lately, and we've kind of refined our stance on this one too, Dan, and that relates to pressure testing. If somebody asks you, hey, what is the best practice for pressure testing my pipe strings before I pull them in a pipe burst, Dan, what do you tell them?
ASTM. It is a little bit more conservative than some of the previous tests that have been, making their way around the HTP and the water and wastewater market. It is a little conservative. It does take a little bit longer than some of the other independent tests. However, it is the golden standard. The one thing we do recommend, I don't know what change you were alluding at in the pressure testing differences, but if you haven't looked at using a data logger for that test, I recommend you guys go ahead and do so. It really gives you that accountability that it was done, that it passed that 7.5% drop off in pressure, and it gives you a nice reading to put into your report for your as-builds as well.
Okay, so, but what specifically is the test? So it's an ASTM test, but does it last 5 hours? Does it last 12 hours? And what pressures do I use? That kind of thing.
So the first hour of the test, you are allowed to introduce makeup water, and that makeup water keeps that test at pressure. HDP being that viscoelastic material, it does want to swell just a little bit when all that internal pressure builds up. During that swelling, we do provide makeup water because we are creating a little bit more of volume inside of that pipe. After that, I believe the ASTM standard requires it to hold pressure for 4 hours. I'd have to double check that really quickly. But during that time, you are not allowed to provide makeup water, and you are only allowed, I believe, to lose 7.5% of the total test pressure. So for the 200 psi operating pressure pipe, I believe ASTM recommends 1.5 times that pressure, so it'd be 300 psi. Some of those previous tests, like we mentioned, things have changed. Allowed lower test pressures for shorter amounts of time, but like I said, ASTM is a little bit conservative.
Well, if you wouldn't mind, look that up and come back to us here in a minute or two.
I'm doing it right now.
Thank you. Dan, other types of pipe have pressure tests as well, but they don't test their pipe strings above ground. They test them once they've been installed. What do we consider a failed pressure test?
For polyethylene?
Yeah.
If you do lose that 7.5% during that 4-hour holding period. So if you lost 15 psi on a 200 psi pressure test, that would be considered a failure.
Yeah, so we probably have a leak in the pipe somewhere, right, Alan?
Yes, you would see a visual leak. That's what I would consider to be a failure of the pressure test above ground that we look at. So part of what we're doing is we're expanding that pipe to be able to allow that pipe to be able to pressurize and expand. This is the Poisson's effect that we're overcoming. So we would raise and elevate the pressure that we're testing that pressure to. And then after we go through that expansion period, we would reduce that pressure back to about 1.5 times the operating pressure of the pipe, and then observe that test. So this varies. I'd like to take a couple of seconds here and say a big difference between design rating of the pipe and then operating pressure of the systems. So a very commonly used pipe for water systems is a DR11, which has a design rating of 200 psi, but that doesn't necessarily mean that you're going to use 200 psi at every part of your system. You pressure test to what the weakest part of your system is going to be. So that's an appurtenance, that's some type of connection within your system that is not the 200 psi DR11 rated pipe. So once we get to the general operating pressure of the system, so a lot of times they're 55 to 70 psi, then you go up 50% greater than that. 70 psi, we would test to 105 psi, and the stable part of it, and then observe whether or not there's leaks and other things. So the thermal conditions come into effect too, Pete, that if you're pressure testing in the afternoon and your pipe is hot, it will also expand in that manner. So you'll have to look for that. And what we're tracking at the pipe fill process as well is any water that's been added to that pipe, and that would be considered makeup water.
Okay, so if I am testing my pipe and the pipe's 100 degrees, you said I have to account for that. What does that mean? I have to account for that in my pressure test.
So it would be an observation that if the pipe is hot, then the actual pipe would expand in size. So much like during Poisson's effect, that would expand as well. Now keep in mind, everybody out there, that these are micro expansions. They're really small. The amount of amended water isn't 10% of the pipe volume or something like that. We're typically going to see very small adjustments.
But we have to derate when it gets the pipes hot, right?
Yes, you would have to make sure that we don't get to that maximum level. So if our pipe is at 120 degrees, then we look towards the portions of PPI handbook on polyethylene pipe to derate that pipe. All of the pressure ratings are provided at 73 degrees Fahrenheit.
So speaking of Plastics Pipe Institute, they've done a great job of giving us guidance and writing technical notes and technical reports, guys, that we share every week, right? One of those documents that Camille Rubia has shepherded through PPI's Municipal Advisory Board is called AWWA M55. Dan, could you give us the overview of what M55 is and why it really ought to be on anybody's desk that's in this industry?
Yeah, I would say AWWA is not the most extensive HDP resource. The PPI handbook for polyethylene is going to be the most extensive, going really deep on every single detail of every issue that you would possibly need to cover. But that M55 is really the sweet spot for consulting civils. It's very easy to digest. It really boils down the main issues and topics needed for designers. If you're more curious on the basis of their recommendations and calculations, the M55 is more in depth. But it does several things to make HDP easy to work with, including limiting when calculations are needed to be done, and if they are needed to be done, it gives you really clear-cut guidelines and parameters to make sure we're designing within proper windows.
Yeah, we do once or twice a year, Dan, we do a giveaway. We ask people to send in photographs of their favorite project, and last time we gave away like 20 editions with the support of Pipeline Plastics. So we're going to be doing another giveaway this summer to try to get some more photographs of great polyethylene projects. Dan, you brought up earlier the McElroy data logger, and we talk about the importance of the data logger, but you know what, we got to keep talking about it because it really does provide the feedback and the accountability that so many of the people that we talk to want. Tell us about the data logger.
Yeah, so it is your eyes in the field when you're not there, right? An engineer can't spend all day on a job site making sure every fusion is done correctly, but the data logger can be. It does a really great job of tracking pressure over time, and pretty much the whole fusion process, with the exception of heat, is checked. So that parameter is very easy to measure at the beginning of the test itself. But a really good or well-trained inspector can tell you exactly what went on. Even if you try manipulating a data logger to get some fusions to have a different result than what's typically spec'd, a good inspector knows exactly what's going on for each parameter of the test. So accountability, quality assurance, it really is your quality assurance program out there in the field. I couldn't recommend it anymore.
You know, Alan, 2 generations ago, the most common pipe going in the ground was metallic, read ductile, right?
Mm-hmm.
Now, plastics have taken that market share over, and polyethylene shares that with PVC. One of the really cool things that I'm super proud about with polyethylene is it does not suffer from fatigue, yet PVC does. Can you give a little bit of color to that argument and why that is so interesting to the salespeople that are listening today?
Most certainly. Before we do that, I'm going to go back and clarify on ASTM standards for pressure testing.
Cool.
ASTM standard F2164 tells us that we charge and pressurize for 10 psi above that test pressure that we want to achieve for up to 4 hours. And then we reduce it by 10 psi, which is our chosen test pressure. And we look that for 1 hour. If we don't see any visual leaks, or if it stays within 5% of that test phase, then it is considered passing. So that's now clarification on this. So
good work. All right.
Thank you.
Back to fatigue.
Back to fatigue. So we want to talk about fatigue in various products we have, and essentially over time, that surge cycle within our pipeline, basically it accounts for time operation of the system. So if it's just a random pump on, pump off condition, polyethylene allows for 1.5 times the design pressure of that polyethylene system for 55 cycles every day. For all pumps on, all pumps off, or our mass demand events such as the Super Bowl or firefighting, then it allows for 6 times per day for that surge occurrence. So in fatigue, that activity takes it's a toll on pipe material types over the years. So high density polyethylene itself has innovated to be able to have that fatigue resistance. Some of the other pipe materials have not innovated quite like polyethylene has with regard to that fatigue cycle, and the other pipe materials are going to suffer that fatigue for premature failure within operation of that pipeline itself. So since the industry has continued to innovate, they've overcome that fatigue cycle, which is one of the 3 primary causes of failure of pipeline materials, the other 2 being corrosion and soil displacement. Did I suitably answer your question there, Pete?
Yeah, I mean, I suppose, we say, according to a study that occurred, that we can handle 10 million cycles. And that 60-some cycles that you talked about, no way you're getting to 10 million. If you got to 1 million cycles in 100 years, that would be a lot, right? So our ability to handle those cycles and the surges that you talk about is extraordinary. Whereas PVC, it is not as robust in that manner. It's a brittle material, and it suffers from fatigue, and it's one of the ways it fails. Does ductile fail in a fatigue regime?
It will over time, absolutely. So a lot of that has to do with the accommodation of the pipeline for surge. So the surge is going to be a large velocity change within the pipeline, and that happens to be those cycles I'm talking about.
So fatigue is related to pipe life as well. And we had a study that was shared with us from 2021, Alan, where the United Kingdom's WIR, which is their version of AWWA, exhumed pipe samples that were 50 years old or older of polyethylene, first and second generation. And those pipes basically tested new, and their assessment was that they were going to last for 160 years. That's empirical data from the field, Alan. What do we have from the lab that tells us that we also have a robust material?
I'm glad you asked, Pete. We have extensive testing. So this fatigue cycle in the defense of the 10 million cycles that we're talking about comes from actual laboratory testing that the resin manufacturers do upon their pipelines. The extrusion facilities do it upon their pipeline. They also do it at various temperatures, so we can start to understand the temperature impacts on it. But what this looks like in the lab, Pete, is lots of vats of fluid with pipes within that vat of fluid that are going through that surge cycle itself. They're putting them in various temperatures of water to be able to look at failure. So what we're attempting to predict in many instances is up to 3,500 psi for the hydrostatic design basis. Then they'll track those failures to make sure that the failures are occurring in the same fashion out to a defined time period, which is 10 million cycles if we're looking at it. And then as long as the failures are along that same curve for that amount of time, then they predict eventually when we'll get down to the conservative 1,000 psi of yield stress that they've assumed for the hydrostatic design basis. This concept is the entire reason why these pipelines can get their rating through PPI and things of that nature. So it's the true defense itself of, exciting, well, Pete just threw something at Dan, and Dan did a great job catching it. That's why I said it was exciting. But yes, that's the whole basis of TR for TN3. Maybe I got those backwards. Maybe they're TN the other way around. But that's the defense of why companies can produce pipe materials and resin to do exactly what they say it does.
Good job on that. So, Alan, your colleague Dan has kind of become a student of horizontal directional drilling. Dan, could you give us, what is horizontal directional drilling and why is polyethylene the pipe for HDD?
It's a really non-invasive way of getting a pipe in a very unconventional location. So going under a main highway, keeping it operational, an environmentally sensitive area, anywhere where open cut isn't feasible, first thing you want to start thinking about is horizontal directional drilling. It does compete with some other technologies at certain diameters, such as jack and bore and microtunneling, but those are last resorts when you're comparing the three. HDD is much more cost effective. You don't really need a carrier pipe. There's no welded steel is going in to be the host. So typically those projects are, they're choosing drilling out of necessity, but compared to its competition, if you can drill, you're most likely drilling. There are situations, right, where you're going to have to do that micro tunnel if you need a really solid tolerance. So HDD is not a great technology for gravity sewer. If you have 2% or greater slope, yeah, go ahead and look at drilling. Depending on your rock formations, it might be easy to do so, but a lot of parts of this country don't have that 2% slope available.
Thank you, Dan. Let's just go back to PPI one more minute, Alan. You made reference to TNs and TRs. What is that? What are TNs and TRs, and why are they important for us?
Thank you for allowing clarity, Pete. The technical reports and technical notes basically are studied significantly by the Plastic Pipe Institute, various topics throughout the industry in various topics about the behavior of polyethylene pipe. Collectively as a group, everyone at PPI and all member companies will look at those together and then also issue these as general guidance as to how plastic pipe will behave.
Yeah, and you read those, Alan, and you can learn a lot. And you know what? They're free. All that work that PPI has done, and they make them available to us without charge, even if you're not a member of PPI. I mean, it's fantastic. All right, we're getting close to wrapping this up, fellas. I want to hit a couple other top line issues. Dan, you brought up HDD, gave us the quick tutorial on it. Whenever I hear you talking about HDD, you bring up Borade. Tell us about that.
Yeah, so Borade is a free tool offered by PPI, PPIborade.com, and it's great for end users when they're starting to look at a drill. Typically, when you are doing an HDD, it can be an emergency project, that project you guys worked on in Fort Lauderdale, or I guess Miami Beach, I should say. That was an emergency repair situation, but typically these projects are being planned out. They are years in the making before they go into the ground. The nice thing about PPI Borade, it's really good for probably up to about your 60% drawing set. It really lets you know in terms of feasibility what you're going to be looking at for a project. Like I mentioned earlier, these locations tend to be highly trafficked areas or environmentally sensitive areas, so permitting can be a real issue with those projects. Utilizing that tool on the early end can really save you a lot of time and money before you start hiring a consultant. You got to pull the right permits, you got to get the right easements, what does your accessibility look like. It really helps an owner early on start to really get an understanding for what that pipe's going to look like.
Good job with that. Alan, the last topic I want to talk about before we get into what's on the horizon is the ID matching. We've got a lot of salespeople listening, and one of the arguments that competing materials make is that they're a thinner wall, we're a thicker wall, so you've got to upsize that polyethylene pipe to match us. And you know what? That just makes a lot of sense, and that's intuitive. It's logical. Help me understand that whole issue.
All right, so Pete, the theoretical single pipe, no connections, one source pushing it through a long area is where we're really going to be concerned about friction loss across that single pipe area. Pipe networks, pipe distribution networks, gravity sewer collection networks, those types of things have a lot more connections in between. The water goes a lot of different places in potable water networks, so you'll have to really push towards a hydraulic model. So it's a hydraulic model is a detailed hydraulic analysis that looks at all the pipe network within that system, compares the pumps that are pumping the flow, compares the demand on the pipe system itself for calibration of the model, and then it looks at friction loss across all of that function. We've spoken ad nauseum with hydraulic modelers, and the comparable friction factor is a larger component than the actual ID restriction by moving to polyethylene, and that happens for the life of the pipe because we do not lose that interior, or the friction factor does not decrease over time, unlike metallic pipes who will tuberculate, and that whole surface will close in on itself that way. So polyethylene does handle higher velocity changes within the pipeline with less pressure surge, and that's due to the viscoelastic nature of the pipe. So while it seems easy to latch onto, Pete, that because we have a smaller ID, because our wall thickness does have to be a little bit bigger for the pipe, it's simply not as simple as just one theoretical pipe for a long distance.
So there are many occasions, Alan, where we may in fact permit or argue for a smaller ID, and there will be no negative impacts on the system.
Typically not. A lot of times our systems are going to be very robust in what they have, and then you'll be able to move a lot of water in different places. Now, I will say anecdotally from Jared Svagera in Nebraska for us that while they're replacing pipe or putting in new pipe, if they're worried about a constriction of that ID, the actual line item price of pipeline material during new construction or rehabilitation is a rather small thing. So you can put in that larger idea if you want to go that route. Also, parts of our industry would send you to a smaller DR rating for your actual pressure operating system within it. But now we're starting to get out of that question originally.
Yeah, it is complicated, and it's not easy to explain in 2 sentences the answer. So what everybody just their fallback is, oh, you got to match IDs. And ID matching is not necessarily required with polyethylene. In many cases, it just isn't. So guys, what's on the horizon for polyethylene? What's on the horizon for us here the rest of 2024? Alan, what do you got on your list for what you're looking for in the second half of the year?
Second half of the year, Pete, I'm looking at thrust anchor discussion. So we'll have some great competent engineer volunteers for us later on in this year to be able to talk about design of those thrust restraint systems. Also, PPI has issued a tool, online calculator for thrust restraint as well that we will incorporate in evaluating that. And we'll continue a lot of the same message with great case studies of where we are lining larger diameter pre-stressed concrete cylinder pipes, larger diameter pipes that are nearing the end of its service life, and continue down that path, Pete.
Dan, how about you? What are you looking at here for the rest of the year? Anything new on your horizon?
Everything. No, I'd say the biggest thing is probably the large diameter pipe. The frequency in which we're seeing it's getting a lot more questions, more designers looking at using it for the first time or at an increasing capacity. So we have to keep up with that, and there's a few different things on that front that you and Alan are preparing ahead of the webinar in 2 weeks on XXL pipes, and yeah, I'm excited to see that continue to grow. That's really going to be an exciting development for our industry.
Well, Fort Lauderdale, on that note, just placed an order for 54-inch DR11 that Agri is making. Last year we were talking about 48-inch DR11. This year it's 54-inch DR11. And Dan, in our visit down to Agri, we saw some 64-inch DR11. So we are this industry is making it possible for our municipal customers to use that 200 PSI all the way up into the 64-inch diameter, or 63-inch, which is extraordinary. We're also getting ready for AWWA in Anaheim in June, Alan, and we're going to be doing some pipe bursting there.
We're going to be doing some pipe bursting, Pete.
All right, with that, I think it's close to time. We've talked about thrust blocks, service connections, sewer laterals, pressure testing, AWWA M55, the data logger, fatigue resistance of PVC and polyethylene, the life of our pipe, horizontal directional drilling, as well as ID matching. So guys, great job. We need to do this more often and make this a regular podcast. So with that, I'll say thank you to WL Plastics for sponsoring yet another PolyPodcast. With that, we'll see you next time.